All right. Hi there. Welcome back to the Formulaic Approach channel. In this video, we are going to be talking about environmental pollution. All right. Generally, pollution is described as the release of harmful substances. So we say it's the release of harmful substances in quantities that are injurious or deleterious or in quantities that are harmful, okay, to the components, to the living components, of the ecosystem. All right. So you have to take note of the word harmful. Okay. So there is the release or discharge of harmful substances, harmful or toxic substances in quantities. Now, quantities is also very important because some of the gases that we already release, that we use, or they are already around us or that surround us, are part of the things that constitute pollutants. Okay, so for example, CO2 is what we breathe out. All right, so being what we breathe out, we won't call it a pollutant yet, except it has accumulated in quantities that cannot sustain human health. So when you release substances in quantities that do not support sustenance of life, then we say that it is pollution. Okay, that is pollution. All right. So, and using the context of CO2, like I said, now CO2 is not a pollutant yet until it has accumulated in very high quantity. Now there is also CO, which is carbon monoxide. Now CO2 is carbon dioxide. Then this other guy, CO is carbon monoxide. Look at how to think about it. So you have carbon, then 2 here is dioxide, and 1 here is monoxide. All right. Now these two are very different. So most often we see that CO is oxidized to CO2. All right. So the reason why we choke, for example, in an environment that is smoky, for example, is because CO is what is released in that smoke, carbon monoxide. When carbon burns in the wood, it releases CO, okay? And that's the reason why it's smoky, is because it undergoes partial combustion. It is not complete. If it were complete, fuels actually burn to release CO2 and, other gases, maybe water. But in this case, in the case where smoke is produced, that guy would have undergone partial combustion. So because of that, it releases carbon monoxide. Then carbon monoxide will now react with oxygen in our lungs, oxygen in our, we breathe in the oxygen. So oxygen is available in our body. So the reason why we choke is that when we breathe in that guy, it tends to take up the oxygen that is in us. Do you understand? To form the CO2, and because of that, we tend to choke if we're in a confined environment where smoke is emanating from, or in fact, we get to come around smoke. All right. So that's primarily it, and of course, the oxygen is what makes your heart, reddish, your blood reddish, very reddish. Carboxylated blood is really not as bright red as oxygenated blood. Okay, so that's why people who smoke, They are tenable to have hole in their lungs, darkened heart, blah blah blah. Understand? Alright, so that's just to tell you that this guy is a pollutant. Now other pollutants are primarily classified into natural and man-made. So man-made or artificial, well, you don't call that artificial though. Just say natural and man-made, okay? What is natural pollutants? Natural pollutant is any pollutant that that comes about by natural phenomena, such as, for example, as we see in earthquakes. So earthquakes will lead to release of dust particles, blah, 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 all those things, and volcanic eruptions, okay? So the volcanic ash from volcanic eruption is a pollutant. We also know of forest fires, okay? So for example, in very hot regions of the earth, we know of forest fires that are not started by anybody. So because of very hot temperature, they just spark up, and the leaves or the trees begin to burn up. So why is it a pollution? That is a pollution because it reduces the amount of green life that are in that environment, and the green life already helps us to sequester CO2. Trees helps in the sequestration of CO2, and when they burn up, of course, they won't be available for what? Carbon sequestration again. So they act as what we call carbon sink. Okay, so that is a natural pollutant. So we talked about volcanic ash, we talked about forest fires. Then there is the man-made types of pollutants. Example is radioactive wastes, chlorofluorocarbons from aerosol sprays, from from refrigerator. There are many sources of CFCs, okay? So we have chlorofluorocarbons. So it stands for CFCs stand for chlorofluorocarbons, okay? And that's primarily their component. I'm going to show you how it is, okay? So we also have smog. We also have emissions from industries, industrial emissions. For example, industries emit NO2 gas, SO2 gas, sulfur oxide, that later leads to this thing, acid rain, because of the formation of fog, a layer of gas, gas entrapped at a certain layer of the earth. So for which reason, when rain is falling, it percolates the gas and falls, mixes with the gas as mild acid, okay? So it forms acid rain. So we have H2O plus, for example, in an area where SO2 forms the fog that I talked about. So you have H2SO3, a mild acid formed, okay? All right, so that's primarily it. Those are man-made pollutants. Now let's talk about the types of pollution. Number one, we have, so I'm talking about the types now, the types of pollution. We have one, air pollution. Now, what is air pollution? Air pollution is basically discharge of harmful substances, like we said, to the air, to the atmosphere, okay? And we classify these guys based on the components of ecosystem that they affect. So the ones that affect the aquatic environment, we call them water pollution. We call it rather the phenomenon of polluting the water. We call it water pollution. So that is discharge of wastes or harmful substances into the water. Okay, so it could lead to death of aquatic life, blockage of waterways, blah, blah, blah. That is water pollution. Now, water pollution can also be natural and synthetic. All these types of pollution can, this one, air and water, can be natural and or man-made, right? Or caused, okay? We call it an anthropogenic influence or anthropogenic causes. Is that okay? Those are causes due to man activity, human activity. Anthropos refers to the man, then genic, that is source, okay? So anthropogenic source, that is human-induced phenomenon, human-induced pollution, human activity induced. Just, you understand what I'm saying, yeah? So the point is that they are both natural and human caused. So we have water pollution, we have land or soil pollution. So primarily we focus on their effect on agricultural environment in this case, okay, where the soil loses its nutrients faster or is unable to is not as fertile as it ought to be because of pollution. Or sometimes the earth or water, in fact, also can become too fertile, okay? In that case, it leads to a phenomenon known as eutrophication. Eutrophication. Now you see the word eutrophication, the word EU means true. It means what? True. And trophos means feeding. Trophos means feeding. So we have true feeding is actually, the word eutrophication actually contextually means overnutrification. That is, there is too much nutrients. We call it nutrient overload. So yes, that can also be a pollution, yes. So if you have seen a water, for example, that becomes greenish over time, okay, it is because of nutrient load. Then you ask me, where does the nutrient come from? For example, in a pond that suddenly becomes greenish on the surface, and we call that greenish thing, we call it algae bloom. Algae, that is, or some of you call it algae. It's actually algae bloom. So that is cyanobacteria accumulating on the surface of that water because of nutrient loads. So like I said, you might be asking where the nutrient comes from when nobody actually nutrified the water. Now, when there is such stagnant water, for example, organisms begin to thrive there, such as mosquitoes, other insects that are aquatic in their early lives. They thrive, and because of that, and over time they might die, and their body disintegrates in the water, and that disintegration results in nutrifying the water. So because of that nutrient in the water, it enables spores of algae, for example, that might have entered that water from anywhere or everywhere, to begin to populate itself in that water, okay? And you would agree with me that they grow very rapidly. And of course, they have short lifespan. But of course, they undergo what is called primary succession, secondary succession quickly. Do you understand? So as one generation is dying off, that generation that is dying off nutrifies the soil, the water again, or the soil itself, in fact. Do you understand? That is why you see some environments, they promote the growth of weeds rather than even the plants. Do you understand? Because some of such plants that you have, there is weed and there is crop. Okay, so let's use crop, for example. So the crop you have there, the plant is the general name. So the crop is what you planted to eat, okay? Now the weed, the crop you planted there has specificities to the kind of environment that it thrives in. So when there's nutrient overload in the soil, for example, that nutrient overload will cause may be a misnomer for that plant, that your crop rather. So because of that, it will, have adverse effect on the growth of the crop, but will propagate the growth of other weeds that can thrive. And they are invasive species. They are species that are almost uncontrollable. We call them cosmopolitan. There's one word, nuisance species, yes. They are nuisance, do you understand? So they thrive almost anyhow in any environment, or such environments that have nutrient overload. So because of that, you think that the soil is bad because it's permitting the growth of the weed and disallowing your crop to grow well. So that's primarily what we see in land and soil pollution. Then we also have the noise pollution. Now, noise pollution is basically, or noise. You see, there are two words. We have noise and music. Music is just a set of sounds that have regular pattern and forms and is pleasant to the ear. While noise is non-rhythmic, irregular sounds that is non-pleasing to the ear, for which reason we call it pollution. It is essentially called pollution if the intensity of or the amplitude of the sound is high. Now, the next one is, we have, which other pollution do we have? We have thermal pollution. We have thermal pollution. So what thermal pollution is just the heating up of a surface. For example, the surface of the earth can undergo heating up. And I'm going to explain something about it under greenhouse effect rather. Then we also have radioactive waste, radioactive pollution. So radioactivity is just basically, radioactive waste is just any nuclear reaction that leads to pollution of an environment. So for example, there's somewhere in, I'm sorry, I can't remember the place now. That place, people don't visit the place again because during the Second World War, I think, that place, because of nuclear activities there, that place is now being polluted with radioactive emissions. Okay, radioactive emissions cause that place to be unsafe. Okay, because what do those things do actually? So, for example, you will know that those of you that have taken X-ray or some of this radioactive therapies before, they will tell you there are specific ways. There are specific ways the treatment is done, because when you expose your skin, for example, to them, they can agitate your skin, and in one way, by that agitation, they can cause proliferation of the cells of the skin, like uncontrollable proliferation of the cells of the division. That's cancer. That's what I'm trying to say. Cancer. They cause skin cancer. So that is basically what happens. Okay, and that's why people that have been exposed to wrong radiation like that, they tend to have certain bodily defects. Okay, so that's primarily the types of pollution in an overview of that. So basically we want to talk about the air pollution. Now, under air pollution, we are going to begin with ozone. Ozone. Now, what is ozone? Ozone is basically an allotrope. Yes, it's an allotrope. So it might look confusing now. It's actually not confusing, okay? Okay, because now isotope is, you see the word iso means same, tope means unit, okay? So similar units, because they have the same atomic number but different mass numbers, because they actually define the number of neutrons. But allotropes, I want to demystify between isotope and allotrope. Allotropes, the word allo means, I think another, yes, or different, or something like that. While trope would also mean like unit, something like that. But basically this one is, allotropes are substances that exist in different forms in the same physical state. So it is still the physical state, but in different form. So ozone is an allotrope of oxygen. It's an allotrope of oxygen. So basically, physically speaking, it is not very, it is what's it called now? It is harmful to to us too, so we cannot inhale it, okay? But primarily ozone, and we have the formula O3, okay, is an allotrope of oxygen. Now, what do we have to talk about ozone? Now, the earth is composed, the layers of the atmosphere of the earth goes like this. You have the troposphere. I'm not going to give you everything, okay? Troposphere, I'll just give you the ones that are of consequence to this topic. So we have troposphere, we have the stratosphere, then we have the thermosphere, then we have the mesosphere, or is it mesosphere or mesosphere? I think it's mesosphere. Then of course we have the, I can't remember the rest. But these are the ones that, I mean, these two are the ones that are of consequence to what I'm talking about. So troposphere is from a layer of the atmosphere, in the layers of the atmosphere. So think of, in order to be able to envisage this thing correctly, think of the earth like a huge onion, for example. Yes, a huge onion. So the center of the onion, not exactly the center, but like the very fresh inside there is the troposphere. Okay, the troposphere is the one that is closest to us. It goes from 0 to about 12 kilometers altitude above the sea level. So above sea level, from 0 to approximately 12 kilometers here, from here upward, that is the troposphere, and that's where it ends. Okay, so just between the troposphere and the stratosphere there is a tropopause. Okay, troposphere is the layer of highest turbulence, but I'm not dealing with that right now. I just wanted to know that, I want you to know where the ozone layer is found on the earth. So now when you after that layer in the onion, the other layers surrounding it are the remaining layers you see here. So the layers covering it is going to be the layer immediate after the troposphere is going to be the stratosphere. So the stratosphere exists at about 12 kilometers to about 50 kilometers above sea level. Then this one exists from about 50 to, I think, 600 kilometers. This one exists from 600 kilometers to about 800 or so kilometers. So, but basically, now the stratosphere is where we see the ozone layer. The ozone layer. So the ozone layer is a layer of gas consisting primarily of ozone, of course. That's why it's called ozone layer. So there is a layer of gas surrounding the troposphere or above the troposphere layer that helps in preventing now you see the radiations that come from the sun. We have one of the harshest radiations from the sun is called UV, or ultraviolet radiation, and they are of two forms. We have the UVB and the UVC. Okay, so I probably don't know which one is deadlier, but you don't want to know either. so these two radiations come from the sun, and of course the ozone layer is a very important layer of gas above that troposphere, at about 35 kilometers above sea level. It is that layer that we find around that region that helps us that prevents about 97 to 99% of the UV radiation that comes from the sun. Now, one thing about UV radiation is that it can fry you. Do you understand? Yes, it can fry you. It cannot fry me because, you know me, I'm not, so basically it can fry humans. It's very deadly, okay? So, I remember the last time I visited the sun, I needed to, let's leave that story. But the point is UV is very deadly, and it exists, it helps us to shield, or it shields us from about 97 to 99%. So primarily, very, very less than 2% of UV light actually get to the earth. So even the hottest regions of the earth don't enjoy more, not enjoy, they don't have more than about 2% of the harsh radiation of the earth, so of the sun. So it tells you how strong that radiation is. So even when you are saying the sun is scorching, so imagine if the ozone layer were not there. And that's why we are talking about pollution, because the ozone layer needs to be there. Okay, so now we have to talk about what is called the ozone layer depletion now. Ozone depletion. Now it forms like a thick bag, a thick a thick bag of gas, okay, a thick bag of gas that helps to shield us from those harmful radiations, okay. Of course, it is not only the ozone layer that shields us from the UV radiation, yes, radiation of the UV radiation. There is also the magnetic field of the earth also shields us from it, yes, by deflection. So, but we are not doing that right now. So we're focusing on what the ozone layer does. Now, what is ozone depletion? Ozone depletion simply means the like eating up or thinning. That's a good word for it. Thinning. Thinning means when something is eaten up little by little and little by little and little by little. So imagine this were the earth, and there was a thick gas here. Then little by little, the gas is now getting eaten up. You know, it's getting eaten up. Okay? It's getting eaten up. So what do you see now? It's thinning out. Makes sense? It's becoming slimmer and slimmer and slimmer and slimmer and slimmer. Okay? So what will happen over time? Over time it's going to disappear. Yes, it will disappear because when it's eats up completely, you won't find anything again. Okay, so then you now ask me, so when it eats up, what will happen? Will the earth disappear? Well, I don't know. The last time it happened, that was before the beginning of the earth. I remember what happened then. I can't remember. I'll tell you the story later. So the point is that this guy is thinning out. Okay, so that's what we call ozone depletion. Now, why does it deplete? Why does it deplete? It depletes because of what we call greenhouse gases, or greenhouse gases. I'm going to tell us what greenhouse effect is. But first, greenhouse depletion occurs because of greenhouse gases. Before we talk about that, there was something I probably didn't mention. This ozone, O3, you might be thinking of how did it form. Okay, during the formation of the earth, one of the things that happen is that, because if natural phenomenon help us to understand this, okay, that you know that oxygen is O2, right? Now what happens is that of that very small percentage of the UV that still gets there, that small UV is able to ionize, not even ionize, it is able to break the O2 bond, okay? It breaks it and releases, so UV causes this guy to break up into O and O. And these are primarily radicals, or they are radicals or radical-like in function. They are in their property because they are very reactive. So what happens is that this guy will now combine with another O2 to form O3. Okay, this process primarily occurs during lightning. So lightning helps to ionize the gases and cause them to be very more reactive, and that process both makes and destroys ozone. So that's how ozone is being created. So that's a natural phenomenon that helps us to know that was how that thing was formed over time. Okay, now I'm going to tell you why life on Earth is pro-life. Why Earth is pro-life, rather. Now, I now said that this guy, ozone layer, is depleting. How is it depleting? Because of the following: emission of chlorofluorocarbons. Okay, chlorofluorocarbons. Now, what are chlorofluorocarbons? Chlorofluorocarbons, or CFCs, are basically gases from some substances that we already use, like our refrigerator. This guy comes from refrigerator comes from aerosol sprays. Our aerosol sprays, all those fleets, all those guys. This guy too, there's one guy that came to my head just now. Primarily these guys, CFCs come from this guy, and they cause ozone depletion. Let me show you the chemical reaction of how it occurs. So we have CFCs, chlorofluorocarbon. I'm going to use a typical one in our aerosol, which we call CFC12. So CFC12 has the chemical formula CCl2F2. Okay, so this is CFC12. Now what happens is that this CFC12 undergoes radical heterolytic fission. Actually, is that heterolytic? That will be heterolytic. That will be homolytic fission. But it's within the same molecule though, within the same molecule. But it will be the bond between F and F that will be broken, or the bond between C and C. So I'm going to use the C and C, okay? To the bond, the C and C, Cl and Cl rather bond will be broken. So we have under the influence or in the presence of UV light, this guy breaks to CCl, C, so let me use CF2Cl dot. So this is a radical. So, and what did I say about radicals? They are very reactive, extremely reactive. In fact, so reactive that just know they are very reactive, very reactive. So this CFC, so this guy becomes radical, and as it is a radical now, Cl radical has also been formed. Cl radical has also been formed. So it is this Cl radical that now comes. What it does, it reacts with ozone. So what it does is when it is emitted, it will go to the ozone layer, go and pick up a mole of ozone, okay? And I want to show you why it is the craziest now. It is the harshest, harshest enemy that this guy has. So I'll mention them as greenhouse gases. I also mention them, okay? But I want to use this first, okay? So this radical will go to the ozone layer and tell ozone, give me small ozone. And that they actually communicate. Yes, I've been there before. I saw ozone and this guy, they're talking, you know. So this guy will tell ozone, give me one ozone, then snatches an ozone. Now when he snatches ozone, what he forms is another stronger radical, which is ClO dot, okay, oxochlorate radical, now plus O2. So what it does is that after forming this is stable, so it will leave. What will now happen is that this guy, ClO dot, then we now react with another oxygen, okay, because it's very reactive. We react with O. Now this O, how is this one formed? You know already by natural phenomena. I said some of the small UV light that still percolate, penetrate the earth, can actually already break this O2 into two, right? Into O2, oxygen. Do you understand me? So this guy is very reactive. So what he does is that this one is already made available by the action of UV light on ordinary oxygen. So this guy reacts with this guy and forms what? Cl dot again, chlorate radical again, and because of that, plus O2. So that one leaves. So what will now happen? This guy becomes reactive and the process repeats itself. Do you understand? So this guy again will go back to the ozone, pick up again, and until it keeps recycling itself like that, the process, and until only one mole of this guy can take up to 10,000 ozone. Do you understand? You see how massive that is? 1 to ratio of 10,000 ozone. Do you understand? So that is how very reactive these guys are, or very deleterious these guys are, because of that condition of having to recycle and happen and take off oxygen, and so that is why these guys are very reactive. Now let's mention the greenhouse gases. The greenhouse gases that we have are these guys, like I said, CFCs. First, what are greenhouse gases? I'm going to tell you why they are called greenhouse. Why it is called greenhouse first. So we said greenhouse gases. So now example is the CFC. Another example is methane. Another example is nitrous oxide. Okay, nitrous oxide. We Their impact name is dinitrogen 1 oxide. Okay, we have many more. Okay, even carbon dioxide, like I said, is also a CFC. Yes. It's also a GHG. That's the general name. That's what greenhouse gas mean. Okay, greenhouse gases. So CO2 is a greenhouse gas as well. Then you might not say, so does CO2 deplete the ozone layer? Now, that is a greenhouse gas does not mean it actually depletes the ozone layer. But I'm going to tell you how the effect of greenhouse gases, okay? But primarily, these are greenhouse gases, and this is the one that primarily, depletes the ozone layer. This guy, methane, also depletes the leads to global warming primarily. These guys all lead to global warming. Now let me explain what global warming is. Let's start with greenhouse. What does greenhouse? The term greenhouse, what does it even mean? Now, a greenhouse is basically a small structure, maybe not small, but a structure where heat, okay, it is made of glass, okay, made of glass or any particular material that can allow light to penetrate. So because of that, when the light waves penetrate, they will heat up the gases confined in that greenhouse, and that gas will not be able to leave, will not be able to escape the wall of the glass. Make sense? The gas cannot escape because the gases will absorb the heat energy. Make sense? The heat energy that comes from the sun comes from the infrared radiation. The infrared radiation, okay? So they will take up that heat from the infrared radiation. They are going to, use it to warm the environment of that, of that greenhouse, okay? That's how we call it greenhouse. Now, why do they now call the condition of, the condition that leads to global warming, why do they call it greenhouse effect first? Now, greenhouse effect occurs, scientists saw greenhouse effect as that phenomenon looks or is similar to the phenomenon of greenhouse for that I just explained, that that we use to maybe grow some things. That's what we primarily use greenhouse for, to a controlled system where we can grow stuffs. Okay, so basically, I'm saying that greenhouse effect is the term that was coined for that condition, because it looks like the earth was also a layer, a ball like that also permits the heat to come into the earth through the infrared radiation, and the gases in the atmosphere will absorb this heat. Some of the gases that absorb this heat include CO2, include even water. Water vapor is also a greenhouse gas. Water vapor. So all these gases, they absorb the infrared radiation as heat, and when they absorb them, those gases, they don't escape the Earth's atmosphere. Do you understand? So because they don't escape the Earth's atmosphere, so that's why that condition now looks like a greenhouse condition. So we call it greenhouse effect. Now, they are actually more deadlier than one another. So for example, CO2 is the least deadly. CH4 is about 25 times deadlier than CO2. But I primarily want to talk about global warming. So why does global warming occur? Global warming. Now, global warming is just a condition where the earth is warming up. Yes, that's the meaning. Global warming. The earth is warming up. Now, why would the earth warm up? Okay. There are many conditions that will lead to it. Okay. These conditions, they have effects that are quite. It is what's it called now? A reflux, okay? It's a reflux, such that one effect leads to another, leads to the beginning of another bad, do you understand? Another bad effect, do you understand? Let me explain. You're going to get it in the context now very well. So, for example, when there is when CO2 takes up heat and gets heated up, okay, they don't release the heat. Makes sense? So because they don't release the heat, and those gases do not escape the Earth's atmosphere, they will stay in the Earth's atmosphere. So causing the Earth's temperature to rise. Now, then again, you might have heard that deforestation causes that guy. Deforestation causes global warming. Why? The reason is that in deforestation, we are removing the plants that are supposed to sequester CO2. So in as much as they are absent, then it will make the amount of CO2 become what? Nuisance. Will aggregate a nuisance amount, and because of that, they will, take up heat. And because they are heated up, they are not leaving the atmosphere, cause the atmosphere to be warm, as well as these other gases that I just mentioned. Now, nitrous oxide is even deadlier than methane. It is about 100 times deadlier than methane. It is a very bad greenhouse gas. Do you understand? It takes up heat. It takes up heat and absorb heat from the infrared radiation and does not release it. Is that okay? Now, what are the effects on this thing? In the atmosphere, we already know that it's going to cause what? Global warming. It's going to be a warming. And when there is global warming, so what are the effects of that global warming? That was what I meant to say. What are the effects of that global warming? The ground will become more heated up, and because it has heated up, there are some heat sensitive nutrients in the soil. So those heat sensitive, there are some heat sensitive nutrients in the soil. So those heat sensitive nutrients will, they can get heated up, and they will lose their nutrient. They will fry off. Do you understand? So because of that heat in the soil, they will get, think of it like being fried. Okay? So those nutrients will be removed, and because of that, the soil cannot yield good the soil will not produce well. Okay, the produce of the soil will be bad. Why? Because the nutrients are not available. The ground is heated up, and because of that, of course, in dry season, you understand, the ground is heated up, a lot of heat removes both water and nutrients. Do you understand? So because of that, the produce of the land is bad. Then even on the water, so when there is high temperature, high heat, the planktons of the soil the planktons of the water rather, we have two types of planktons on the water. We have the phytoplanktons and the zooplanktons. Now the phytoplanktons, the word phyto means, anytime you hear the word phyto, it means plant related. Plankton means, it's from the word planktos. Planktos means water drifter. That is, they are not mobile by themselves. They drift with the wave of the water. Okay, so phytoplankton, they are stationary. So unlike, we have two types of this thing inside this thing. We have planktons and nectins. So nectins are the ones that can swim against the water drifts. So planktons are stationary. So since they are stationary, or more like they move, they drift with the water, they cannot control their own movement. So if the water is hot, they don't have a hiding place. They stay there, they get scorched, dried up. Do you understand? So phytoplanktons are the plant planktons in the aquatic ecosystem, and they form the base of the food chain in the ecosystem. So they are the ones that the higher planktons, zooplanktons will feed upon, then the propagation of that food chain thing like that. So the phytoplanktons get dried up, and because of that, because of the heating, the environment will become, when an environment, there is emigration of species out of that environment. There is emigration of species. There is I've forgotten the name they call it. It's like, what it means is abandonment. They abandon that environment because of it doesn't support their living conditions again. Okay, so, and of course, over time, that environment will lose its essence. That environment will lose its essence. And remember, it started from the what? Wiping off of the basal food or the basal trophic level. Now, So that is the effect on the water, the aquatic ecosystem, will lead to warming of the sea. And in fact, another thing is that some organisms will literally, apart from phytoplankton or nectins, some nectins will die off. Yes, some nectins will die off. And like I said, migratory species will definitely leave that environment and go to a more suitable environment. So the other part of the ecosystem that were dependent on that nectin will also die, or maybe not die, but will be adversely affected. So if they are adversely affected, then what is happening there? There is, there's going to be abandonment of that ecosystem, or the ecosystem will lose its essence, it will lose its vitality, and because of that, will not might cease to exist. Will go into extinction. Yes, will go into extinction. So so that's the effect on the water. Then of course, we also have the effect on land. Like I said, okay, I've mentioned land. In the air too, global warming causes the atmosphere to heat up. It causes the atmosphere to heat up. And in fact, as time goes on, some of these gases, like I mentioned, CO2, SO2, they will accumulate in the atmosphere. And by the time, before you know it, what will happen is that they will form fog on the atmosphere, that layer of gas that is not going to allow heat to leave. So heat that is coming, the earth is a good emitter. So it emits heat that, land and sea breeze, okay? So it emits heat. That heat that is supposed to go to upper atmosphere will not be able to leave. So for that reason, that environment over which the fog is formed is going to be hot during that moment. So those are the effects of this thing, of global warming. I hope I've been able to do justice to the topic and environmental pollution. If you do have any questions, do want to put them in the comment section. I will answer them as soon as possible. God bless you. And subscribe to the channel.